All right, guys, I've written this on the board here. We call this an equation. Can anybody tell me why it's an equation? Oh, Liam.
Because of the equals.
Because of the equal sign. Brilliant. So great. All right, thank you, Ian. He just loves to dispense knowledge in class. Thank you for that. All right, so that's exactly right? We said when we were working through the quiz a minute ago, an inequality by comparison has either a less than or greater than sign of it, right? So if it's got an equal sign, then we call it an equation. And what we remember, one of our rules, our algebraic rules, is that I can multiply the left side of the equation by any number as long as I do what? If I what?
As long as you do it to the other side.
As long as I do it to the other side, right? As long as I can multiply this by 3, as long as I multiply this by 3, right? I can multiply it by 1/2. As long as I multiply the other side by 1/2, right? Any number that I multiply by on one side, I got to do the same thing on the other side. And so what that means is that if I were to multiply this through by 3, like I did right here, it means the equation that results from that, like in this case it would be 3x plus 18 equals 6, right? I hope everybody knows that that would be what the answer would be to that when I multiply both sides by 3. What that means is that these are equivalent equations, all right? So the original equation, which was x plus 6 equals 2, this original equation here and this new equation that we made from multiplying both sides by 3, they're equivalent equations. They are graphs of actually the same thing. Like if I simplified these down, both of them would give me a final answer of x equals -4. If I simplified this guy, moved everything to one side and solved for the x, I would get the same answer. X is equal to -4. All right, so they're equivalent equations. The graph of them looks the same. And the point is we're allowed to do this, all right? And so we're going to use that fact. We're going to use the fact that if we multiply through by a value, as long as we do it to both sides, that we don't change the overall value of the equation. We're going to use that to our advantage in solving a set of equations, all right? Now we have previously solved a set of equations using a concept called a concept called substitution. All right, and so when we had something like this, and we had a set of equations like x plus 2y equals 8, and 5x minus 2y equals 4. Right. In fact, the test that I'm sitting home with you guys, you're going to have at least one problem on there that says solve this system of equations, which means I want you to find the value for x and the value for y. And the way that we've learned to do that is through a process called substitution. So how does substitution work? You guys remember? Can anybody walk me through that process? Liam, is that a yawn, or is that were you saying you don't need to see my identification? These aren't the droids you're looking for.
You use each equation to help each other?
You do. You use it to help each other, and because we call it substitution, the idea is we're going to take one of the equations and we're going to substitute a value from that equation into the other equation. All right. So with substitution, what we did is we took one of our equations and we solved for a variable in there. Right?
So you're trying to get x alone over first.
So we try to get x all by itself. We got to solve for a variable. So this becomes x equals 8 minus 2y. Right? So everybody see I just moved the 2y over so that the x was all by itself. And then with substitution, we take this x and we plug it in right here into this equation. And so we say 5 times 8 minus 2y, since that's what x is equal to according to this equation, minus 2y equals 4. All right, this is substitution. So we solve for one of the variables, and then we take the value of that variable, we substitute it into the other equation, and we just simplify this guy. So by doing that, we've now made this equation only have one variable, so we can figure out what the value of that variable is. So we can figure out what y is by, we distribute it first. 5 times 8 is 40. 5 times -2 is -10. Y minus 2y equals 4. We combine together our like terms over here, making this a -12y equals, and we move the 4 over to the 40 over to the other side. So 4 minus 40 is negative 36. And then we multiply, we divide both sides by negative 12. And so we get that y is equal to positive 3. So that's what we get for that one. And then how do we figure out what x is? Yep, Alexa? You plug in 3 for y, right? And the easiest equation to do that in is this one right here that we've already solved for x. So we plug in the 3 for the y, and we say that x is equal to 8 minus 2 times 3. And so that's 8, times 3, sorry. That's 8 minus 6, and 8 minus 6 is equal to 2. So those are our answers for x and y. And how do we typically write that? Yep.
You put it in parentheses and it's the x and the y. So
Right? Does anybody remember what we call that? So we write it like this. We would say in parentheses x is equal to 2 and y is equal to 3. What is that called? You could call it a coordinate. Usually in these problems they refer to it as an ordered pair. All right? When you start working with equations that have 3 variables in it, you list all 3 of them out and you call it an ordered triple. But here you have an ordered pair, and when you write it as an ordered pair, this is your x value and this is your y value, right? Does everybody remember that? You need to for the test that you're taking home, all right? So make sure you know how to do that. So this was substitution. Now we're going to learn how to solve the exact same system of equations, but through another process, an alternate process called elimination, all right? I'm going to keep this answer on the board because I want you to see you'll get the same answer either way, all right? So I should have checked and made sure I didn't make any math errors before I erased that. Was that the answer? Y is 3. Yeah. Did they solve the whole thing? I guess they didn't solve for the x, but that's okay. Yeah, x equals 2. Cool. All right, so we're going to do the same thing now, but we're going to use elimination. So substitution, we called it substitution because we solved for one of the variables and then we took the value and we substituted it back into the other equation. All right? We're going to call this elimination because we're going to use that little trick that we were talking about at the very beginning where we can multiply both sides of an equation by the same thing, and the resulting equation will be an equivalent equation. And then we're going to add our 2 equations together, and it's going to eliminate one of the variables. So that's why this method is called elimination. When to use one above the other? It depends on the problem. It depends on which one's the easiest one to use. Sometimes one will just be easier than the other, and you look at it and go, oh, elimination would be perfect here. Now, when I see this one, I look at this one and I go immediately, elimination is the way to go. And the reason why is because I notice that if I add these 2 equations together as they are, I don't even have to do anything to them. If I just add them together as they are, do you guys see that one of the variables is going to be eliminated? If I add these 2 equations together, which variable gets eliminated? What? The y, right? Is that what you said? I hope that's what you said. Because I'm going to write your name on the board. That's what you said, right?
Yeah. Yeah.
All right. So Ada very quietly mouthed. And she's right. Because if we take a 2y and we add to that a negative 2y, the y's go away. Does everybody see that? And what are we left with? We're left with 6x equals 12. Right? We're left with that equation. And how do I solve for x if I've got the equation 6x equals 12? Divide both sides by 6, right? We're masters at that now. So x equals 2. That's exactly what we got when we used substitution. But it sure was a lot easier to get to it with this one, wasn't it? So elimination sometimes can be your friend because it's a lot easier to go that route than going the substitution route. All right? So we got x equals 2. And how do we figure out what y is? We do the same thing that we did before. We got to take this x and plug it into one of these equations up here. I can plug it into either one. Which equation do you think would be the smarter equation to plug that into? No, first the top one or the bottom one? the top one, right? Why? Well, because it's just simpler, right? There's no number in front of the x. It's just, this one just looks simpler overall. So I would pick this one, but either one would work. Either one will give you the same answer. So I'm going to plug my 2 in for x. So I get 2 plus 2y equals 8. And from there, I'm going to move the 2 over, so I get 2y equals 6. And then I divide both sides by 2, and I get y equals 3, right? So I end up getting the same exact ordered pair that I got when I used substitution. But it was just a little bit simpler, all right? So the equations will sort of dictate which one's the best one to use. However, at least while you're learning this process, I'm going to give you some problems. I'm going to explicitly ask you to do it using elimination, all right? So you guys need to get good at using elimination. I'll tell you what probably is going to happen. You're going to learn both methods, and you're going to end up favoring one. I teach a pre-calc class at another school, and I was teaching, we were reviewing this just the other day, and they were like, one of the students was like, yeah, I don't remember how to do elimination. I just always use substitution. She got that one down, and so she's like, okay, I understand how to do that. I'm just going to stick with that. But it can really make your life hard sometimes if you only know one way. So learning both of them is going to make it easier with some, so you can choose the best tool for the particular set of equations that you're working with. Any questions about this? We'll try it again. I just want to make sure you guys got that. You guys understand that? All right? All right, so let's try elimination using something that's a little more complicated. It's not as obvious which one we want to use, but still remembering our rule that we're able to multiply both sides by a number. You can see pretty quickly what the simplest way would be to use elimination in this problem. All right. So I want to eliminate a variable. Which variable do you recommend that I eliminate? Again, remembering that what we're going to have to do, since none of them are opposites of one another, exact opposites of one another the way it was in the last problem, I'm going to have to multiply at least one equation by something on both sides. Which equation would be the one to do that to? So that we can eliminate a variable. Alexa?
The one with y by itself.
Say it again?
The one with y by itself.
The one with y by itself. Why would you choose that one? So this is the way that I want you guys to think through this. Is there a easy, simple number that I can multiply this top equation by? That if I do that, then when I add the resulting equation to this equation, that it would be easy to eliminate a variable? I don't know that I said that the best way. But the answer is yes. Is there a number that I can multiply the top equation by? And if I do that, then I can add it to this equation here, and it would be easy to eliminate, in this case, the y specifically. What could I multiply the top equation by? And the resulting equation, if I add it to this, would eliminate the y. Which number? 4, right? You guys see that? So we could do it like this. I could do a 4 on each side, like that, to say I'm multiplying both sides by 4. Here's the way that I usually do this, just because it's less writing on my paper, and it's effectively telling me to do the same thing. I just put my 4 out front, and I put brackets around this equation here, and say, okay, I'm going to multiply the whole thing by 4. All right. So my resulting equation is 4 times 2x is 8x. 4 times negative y is negative 4y. And 4 times 13, and it would have to give me something like that. 4 times 3 is 12. So is that 52? Is that right?
Yeah.
26 plus 26 is 52. Okay. So that's what my first equation becomes. Now I'm just going to take my second equation and just move it over exactly like it is. And you notice now that I've multiplied through by 4 on the top equation, we see that when we add them together, what happens? The y variable gets eliminated. Does everybody see that? So now it's just like we did before, right? We add it together, we get 11x. These variables here go away, and we get 55 right here. We divide both sides by 11, and we get that x equals 5, right? And then we could take that 5 and we could plug it back in any of the other equations. I'm going to just choose this original one we did right here, where we had 2x minus y. That's where I'm going to plug my 5 in, equals 13. But we could have picked any of the equations, we would get the same answer. For, wait a minute, I did something wrong, sorry. I need to plug that in for x, my bad. 2 times 5 minus y. There we go. Do I see what it should be? Sorry for messing that up. Plugging my x back into the first equation, and so I get 10 minus y equals 13. And so if I move the y over here and move the 13 over here, I get 10 minus 13 equals y, and so y equals negative 3. And I write that as an ordered pair, so my answer would be 5, comma, negative 3. That's my answer. Any questions? All right. What time did we get done? 11 what? 11:15. 11:10. All right. So I'm going to give you an opportunity to work on those. Let me just say that sometimes you'll see that whenever you're doing your examples, sometimes you have to multiply the top equation and the bottom equation by numbers so that you'll be able to eliminate. All right, and that's fine. It's the same process. It's just you multiply both equations by sometimes the same number. Well, they won't be the same number, by a different number. Multiply top and bottom equation by a different number so that you can eliminate one of the equations. Let's do. Let's do some complex fractions and make sure we understand this. This is less than 68. X over y plus 1 over y divided by x over y minus 1 over y. All right, this looks ugly, doesn't it? That looks really ugly. This is one of those that you just run to your bedroom and put a pillow over your head and hope nobody finds you, all right? What do we do when we have something that's ugly like this? Well, here's our goal. Our goal is we want to get a, simplify. So we want to simplify. Your general goal when you see fractions over fractions is you want to try to change both the top and the bottom so that you just have a single fraction on the top and a single fraction on the bottom. All right? You want a single denominator in both the numerator and the denominator portion of this bigger fraction. All right? So that's sort of our first step. Try to get it to where we've got a fraction up here that has a common denominator and a fraction down here with a common denominator. Well, this one actually is pretty easy because they already have the same denominator. So that means we can do what? Does everybody see, since these guys have the same denominators, that we can combine the numerators together and put them over a single denominator? So what would the result be for the top here?
It would be xy, or x plus y.
It would be...
x plus 1 over y.
Over y, there you go. So we can add the numerators together, x plus 1, and they're both over y, right? And we can do the same thing on the bottom, where we have x minus 1 over y, all right? Everybody tracking with me there? So now that we have that, we have a fraction divided by a fraction. What do we do when we have a fraction divided by a fraction? Yep, Alexa. We're going to multiply by what? What'd you say? Invert and multiply, yes. We're going to invert the denominator. And what do we call when we invert a fraction? That's the reciprocal. So we're going to multiply the numerator by the reciprocal of the denominator. So we're going to say x plus 1 over y times y over x minus 1. Right? Yes?
Wouldn't those just cancel out and answer?
So not quite. The y's would cancel out. So in this case here, because we're multiplying, the bottom one has a numerator, the first one has a denominator of y, and the second one has a numerator of y. The y's cancel out. Yes, yes. But we can't cancel these guys out because they're not exactly the same. If they were x plus 1 and this was x plus 1, then they would, right? But instead, they're x plus 1 and x minus 1. So that would be our final answer. Does that make sense to everybody? All right, so the goal is when we see something weird like this with some fractions that are added together on the top and then maybe same thing on the bottom, the goal is to get one big fraction on top, one big fraction on the bottom, then multiply by the reciprocal of the denominator and make sure everything's simplified. So let's look at something that also looks kind of wacky, but it's the same basic process. And it's not really that hard as long as you follow those steps. All right, so we have something that looks like this. So our goal, just like before, on the top there, is we want to get this, we just want to get one fraction on the top. So how do I make 1 plus 1 over x the single fraction? We'll just leave the 7 on the bottom for right now. Yep.
It would just be 1 plus 1 then all of that would be x.
Say that one more time.
It would just be 1 plus 1 all of that would be x.
No. We have to get a common denominator, right? We can't add these together unless they have a common denominator. What does the common denominator have to be? Remember, this could be written as 1 over 1. Right, if we wanted to think about that as a fraction. So when we do a fraction plus a fraction, how do you add fractions together? You get a common denominator. So the common denominator with this guy would be x. Does everybody see that? So we change this 1 over 1, we change it to be, if we need to have a denominator of x here, then we multiply the bottom times x, but whatever we do to the bottom, we multiply the top times the same value. So we're basically doing this. We're doing, I'm going to write it out much longer than I normally would. We're multiplying top and bottom by x so that we get a common denominator there. So we end up having x over x plus 1 over x, all of that divided by 7. Do you guys see how I was able to do that? This was a 1 to start with. And you might have just seen this as a 1 and go, oh, x over x is 1. Which is fine. You just jump directly from here to here, right? If you recognize that. And then, now we can add these guys together and say that the top is x plus 1 over x divided by 7. So all we did was we combined the two fractions on top because now they have a common denominator and we can do that, right? Now what's my final step? What did we do in the last problem? Multiplied by the reciprocal. What is the reciprocal of 7? 1 over 7, right? And we can think of this 7 as 7 over 1. And so we're going to say that the end result is going to be x plus 1 over x times 1 over 7. And then when I multiply through, on the top I get x plus 1. And on the bottom I get 7x. That would be my final answer. Okay. So the process doesn't change. You just do that each time. Get a fraction. Take your fractions on the top and the bottom, combine them all together into one big fraction, and then multiply by the reciprocal of the denominator after you do that. All right. We are not going to have time to go into the last chapter, so I'm just going to kind of I'm going to do some more practice problems for this. Because the next chapter is the one, when I started all this, and I was like, you guys need to pay attention because this is really, really important. Well, it's what's in chapter 69, all right? And I don't want to rush that. It's too important of a concept to rush that. So let's do, I'm going to set up we're going to do one more problem like this. Make sure that we're grasping this. And then I just want to set up one elimination problem and you guys can go. Let's do this ugly looking thing. A minus 1, a to the negative 1 x plus b to the negative 1 y, all of that over x to the negative 1. That looks pretty ugly too, right? When I see negative exponents, often, not always, but often, my first step is going to be to rewrite it so that I only have positive exponents. All right? So what does a negative 1 times x become if I do that? A1 on the bottom, right? So we just say x over a1. We don't write the 1 since that's understood, so we just go x over a. Everybody agree? Maybe you're jumping. Make sense? And then let's do the same thing right here. So this becomes plus y over b. And then what does the denominator become? Huh? Just 1? So like just this? Oh, if you moved x all the way up there? Yep. We could do that, but what we would have to do if we did this is this whole thing would be in parentheses and we'd have an x out front. All right? That's not how we're trying to tackle these problems. We're trying to get a single fraction on the top and a single fraction on the bottom. So let's just make this a fraction on the bottom. Do you guys see that that would be the fractional form of that? I'm kind of thinking about the denominator separate from the numerator, and I just turn this into a fraction by moving the x to the bottom of the fraction. All right. So this is x to the negative 1 over 1, and I just move the x to the bottom. Okay. All right. Now our rule was get a common denominator here, right? So how do I get a common denominator for this? What do I multiply x over a by to get a common denominator? B over B, right? B over B. Because what's the goal? What's my common denominator going to be? Why'd you do B over B? Because you're trying to get a common denominator of AB, right? And so if I want to have an AB for my denominator here, then I'm going to have to multiply top and bottom times A. Does everybody see that? I'm just going to leave this part alone. All right, so now that I multiply through by that, I get xb over ab plus y plus a, I'll just leave it y in front, ya over ab. So now I've got a common denominator, and so I can combine those together. And I kind of broke my rule. I like to keep them in order, so I'm going to reorganize them when I write it over a single denominator here. I'm going to write this as bx plus ay over ab. All of that over 1 divided by x. What's my final step? Huh? Divide. Well, I've got a fraction on the bottom. So if I want to divide by that fraction on the bottom, my final step is to multiply by the reciprocal, right? So I say, I want to move it up here so we can all see it. Bx plus ay over ab times x over 1, right? So I get x over bx plus ay over ab. And then I can distribute through and get that the final answer would be bx squared plus axy over ab. Does that make sense to you guys? Yep. So I don't have time to set up the last problem, the elimination problem. But like I said, just remember with the elimination, sometimes you're going to have to multiply the top equation by a number and the bottom equation by a separate number in order to eliminate the variable. As long as you understand that, then you'll do fine on this. All right, you guys have a great day. So this is good. Test next week, but a simple homework assignment.